All right, today we're going to talk about section 4.2 from Algebra 2, and really we're going to focus on the graphing quadratics in the intercept form. So what we're going to be able to do is we're going to be able to recognize the intercept form of a quadratic and how to graph quadratics that are in that intercept form. So first thing we need to do is let's review the other form that we've talked about, and that's standard form. So standard form, remember, is y equals ax squared plus bx plus c. The axis of symmetry for this is going to be x equals negative b over 2a. Our vertex is going to be negative b over 2a, and then we plug that in to figure out what our y value is. And our y-intercept of this is going to be 0c. Well, things get a little bit different when we're talking about the intercept form. So first thing we need to do is we need to look at, okay, what is the x-intercept form? The intercept form is y equals a times x minus p times x minus q. Now x minus p and x minus q might end up being the same thing, but for this sake we'll just talk about them as not being those same things. So first thing we need to find for these, we need to find a couple little different things or we need to find different pieces, I should say. First thing we need to find is the x-intercept. And to find the x-intercept, we're going to find the p0, q0. Notice that it's not negative p, negative q. So if you have x plus p, it would be negative p comma 0. I'll show you some examples in a second of what I mean. The axis of symmetry, what that's going to be is you take your p plus your q and you divide it by 2. So really what that means is what I'm doing is I'm finding halfway in between my p and my q value. Last thing is we need to find our vertex, and to do that we plug in p plus q divided by 2. So we plug in our axis of symmetry just like we did with standard form, and we find our y value. So let's go ahead and let's do some graphs. Let's see what it looks like. So again, x-intercepts, they're the opposites of those numbers in there. So my x-intercepts here are x equals 3 and x equals 7. Opposite of these numbers in here, -3, -7. So I'm going to graph those 2 points first. So 0, 3, 4, 5, 6, 7. So those are my x-intercepts. The way we find our axis of symmetry, remember, is we take those numbers and we're going to plug in x equals 3 plus 7 divided by 2. Well, 3 plus 7 is 10 divided by 2 is, so my axis of symmetry is at x equals 5. So you can see again that I put in my dotted line there. I don't need to put that in, but I just like to put that in there to see what it looks like. All right, now we need to find our vertex, and to figure out our vertex, we plug in our x value. So again, our x value of our vertex is going to be 5. We plug that into our equation. So y equals 5 minus 3 times 5 minus 7. So really that's going to be y equals 2 times -2. So y equals -4. So my vertex is at 5, -4. So again, I'm going to graph that point. Now I have 3 points and I want to get to 5 points. So what I'm going to do is I'm going to look in between what I have. I have the x equals 3, x equals 7, and x equals 5. So I have 3, 5, and 7. So I'm going to plug in 4 and 6. And remember, 4 and 6 are going to be the same number. We know what 3 is, it's 0. We know 7 is 0. We know 5 is -4. So let's plug in 4 to figure out what it is. And we plug in 4 or we plug in 6, whichever one you want to do, we're going to get -3 for both of them. So we plot those points, and even if you didn't want to find the other one, you know it's the axis of symmetry, so it goes across. Now we connect our points and continue up. All right, so that's all we have to do to graph using the x-intercept. So this is the intercept form. Now if you guys printed out the notes, there's another one on this page, but I'm going to skip over that one. And I'm going to try a different one. So let's try this guy right here. I'll go over to the x-intercepts, and some of you guys might notice something right away. You might notice that negative out front. We'll talk about that in a second. So first thing I'm going to do is find my x-intercepts, where it's going to equal -1 and 5. Remember the opposites of my numbers in there. To figure out my axis of symmetry, we add those up and divide by 2. Well, -1 plus 5 is 4, divided by 2 is 2. Figure out our vertex. Plug in the 2 up here, so we get 3 times -3 is -9, but it's times a negative, so that's going to be a +9. So let's graph each of these points here. Now I have 3 points on here, and some teachers might make you find 5, but since we're using the intercept form, I'm okay with only 3 points. Find the 2 intercepts and your vertex. So I'm going to connect these guys up, and it's not going to be exact as if I would have found 5 points, but that's okay for this because we're sketching. Now I want you to look. This is opening down. What makes it open down is that piece right there. All right. Let's try this one. Now this one might scare people because of the, again, that 1/2 in front might scare folks. But again, I'm going to skip that and I'm going to talk about that in a second. Find our x-intercepts. -4, 2. Now we add those up. -4 plus -4 plus 2 is -2 divided by 2 is -1 is my axis of symmetry. That means my vertex is -1, and then we plug that in up top. Now when we plug it in, we're going to get 3 times -3, which is -9. And we're going to multiply that by 1/2, which means we're going to get -4.5. So -4.5. Now let's plot each of these points again. Now if you guys look at this parabola, that parabola looks wider to me than the original parabola would be. And if you guys can't see that, I'll graph the original, your parent graph of x squared quick. Now again, I apologize for my beautiful artistic abilities here, but if I pull this down, you can see that that is getting wider than my original parabola would be. So what's making it get wider? It's that fraction. So that fraction out front is making it wider. And if we notice from the first problem we did here on the top there, the negative flipped it upside down. So that number out in front really makes a big difference. It's either going to stretch, shrink, flip it. That's what it's going to do. So you have to, or it's going to do nothing if it's 1. So if you look at these, if a number is less than 1, but between 0 and 1, so basically if it is between 0 and 1, what it's going to do is it's going to make it get wider. If it's greater than 1, it's going to get stretched, so it's going to get thinner. If it's a negative number, it's going to get flipped upside down, so it's going to be frowny. If it's going to be a positive number, it's going to be facing upward, so it's going to be a smiley. All right, so let's look at some more examples to see if you see what I mean. So I'm going to rewrite this one as a, because this one's a little bit tricky just because of the way it's written. It's going to really be -2 times x plus 0 times x plus 4. Now we could do x minus 0, it doesn't really matter, because x plus 0 is still x, so that's why I changed it. Now if you look, it's a -2, so we know 2 things right now. We know it's going to be flipped upside down, and we also know that it's going to get stretched because 2 is greater than 1. So it's going to get stretched, it's going to get flipped upside down. So our x-intercepts of this are, well, it's 0 and -4, which means our axis of symmetry is -2. That means our vertex is -2, 8. So we got -2, go up 8, and I'm going to graph all these points here quick. You guys can see now that it's negative, it's flipped upside down, and it's also going to make it so it has a maximum value. It's also stretched because of that 2. So a lot of things are happening in that graph. Now this one looks a little bit scarier because it's x minus 3 squared. Now remember, this is really x minus 3 times x minus 3. Let me rewrite that quick. This is really y equals x minus 3 times x minus 3. So now our x-intercepts, we really only have one x-intercept because it's both of those are going to be 3. So now our axis of symmetry, if we both are 3, 3 plus 3, so we can write them both out if you want. 3 plus 3 is 6 divided by 2, it's going to be 3 again. We're not going to have 2 x-intercepts if they're the same thing. Our vertex, we're going to plug in 3 for our vertex. And really, 3 minus 3 is 0, squared is 0. So our vertex is at 3, 0. Let's graph all of our points that we have right now. If you notice, I have 1 point. That's it. I found the x-intercept, the axis of symmetry, and the vertex, and they all were the same thing. I have 1 point. That means I need to use my table to figure out some other points. Now I know, just like before, I'm going to go around the 3, 0. So I'm going to make my table a little bit bigger, x, y. I'm going to do 3, 2, 1, 4, 5, 3 zeros there. 2 minus 3 is -1 squared is 1. 1 minus 3 is -2 squared is 4. So I know it's going to be 1 and 4. Graph my points here. And then we just shade it in up there. Now if you look what happened there, my parabola is almost exactly the same, except for it got moved to the right 3 places. So we're still going to have a minimum. It's not stretched, it's not shrunk, it's not flipped. It's the same thing, just moved to the right 3. Now this page I'm not going to talk about, but the reason why I'm putting this page on here is to show you guys that if you guys wanted to learn just standard form and only know standard form, that would be okay. For any tests you're going to have, for anything in real life, you guys, if you know standard form, you'll be okay. You just need to know how to expand each of the pieces out to get the standard form. But the only reason I'm putting this up here so you know standard form is the most important one to know. But I'm going to teach you, I also taught you intercept form because it's really nice to know that one because it's quick and easy. We have one more form that I'm going to talk about quickly, and it's called the vertex form. And it looks a little bit scary, but here's the vertex form. It's y equals a times x minus h squared plus k. So the vertex of this is hk. Notice it's the opposite of what's inside there. We have x minus h, and we're only using positive h here. And we have k as our y value. Our axis of symmetry is going to be at x equals h. So our axis of symmetry is going to be at h. Now we only have one point there, so we're going to have to figure out other points by using the table from that. But I'm going to show you quickly how to graph. I might do one of these. So let's look at this problem here. The vertex, again, we got to do the opposite of the inside there, so it's going to be negative 2, 1. Our axis of symmetry is at x equals negative 2. Is it getting fatter or skinnier? Well, that we have to look at the number in front there. That is going to get fatter because it's between 0 and 1, so it's going to get fatter. We also look at that one to see if it opens up or down. Because it's a positive number, it's going to open up. And that also tells us if it's opening up, that means it's going to have a minimum value. Because opening up, that means we're going down as far as we can go. All right, so now really we only have one point that we found, negative 2, 1. So I'm going to graph that point right now. We know it opens up. So I'm going to plug in some points that are going to, let's see what we can get. Now because I'm looking at that and I need to do the fourth, I need to take it to the fourth, or multiply it by a fourth, I'm going to plug in certain x's here to make it so it works out nicely. The first one I'm going to plug in is I'm going to plug in 0. Because 0 plus 2 is 0, or is 2. 2 squared is 4. 1/4 of 4 is 1, plus 1 is 2. So I'm going to go from negative 2, I'm going to go 2 more to get to negative 4. So negative 4, that's going to get you the same exact thing. Now I'm going to go and I'm going to try 2 for this one. 2 plus 2 is 4, squared is 16. A fourth of that is 4, plus 1 is 5. So again, if I go 2 more down this way, I'm going to get 5 as well. And I'm going to plot those 5 points real quick. Now you guys can see that that one gets a lot wider. Now I understand that graphing these parabolas is going to be difficult, so if you have to rewatch the video, rewatch it. If you have questions, make sure you ask. That's all I'm going to go over for this one. I'm not going to go over any more of the vertex form, but feel free to let me know if you guys have questions.